this video, we're going to look at the scalar product of two vectors. We'll start by defining the scalar product. So, for two vectors a and b, the scalar product of a and b is denoted a dot b. Note the pronunciation of this symbol here, it's a dot b, and is defined as follows. A dot b equals the magnitude of a times the magnitude of b times cos of theta, where theta is the angle between the two vectors. It's important to note that theta must always be taken to be the smaller of the two angles between the vectors. So theta is between 0 and 180 degrees. On this diagram we have here, theta would be this angle. Now, a few things to be aware of are the scalar product of two vectors is a scalar, not a vector, hence the name. And since the scalar product is denoted with a dot symbol, it is sometimes referred to as the dot product. Let's look at some specific cases. When two vectors a and b are perpendicular, like this, we have that their dot product is equal to their magnitudes multiplied together, multiplied by cos 90. But cos 90 is 0, so this is just 0. When the vectors are parallel, like this, their dot product is their magnitudes multiplied together, multiplied by cos 0. Cos 0 is 1, so this is just the magnitude of a times by the magnitude of b. At this point, it's important to note that there is an alternative but equivalent method for computing the dot product. This method uses the vector's components rather than their magnitudes and directions. So, if we have two vectors in component form, say a equal to a1i plus a2j and b equal to b1i plus b2j, then their dot product is equal to a1b1 plus a2b2. Using the cosine rule for triangles, we could show that this definition is equivalent to the first definition we gave, but we won't go through that proof here. Taking these two definitions together, we have all the tools to calculate the dot product, regardless of what forms our vectors are given in. Let's see some examples. So, question 1. Calculate a dot b, where a is 5i minus 9j and b is 9i plus 3j. So let's put these on our axes. Here's a, and here's b. Now we have the components of each vector, so to solve, we just use the second of the two methods we described earlier. A dot b is 5 times 9 plus minus 9 times 3, which is 45 minus 27, which is 18. Now, question 2. Calculate a dot b, where a has magnitude 8 and direction 45 degrees, and b has magnitude 10 and direction 240 degrees. So a looks like this, and b looks like this. This time we must use the first definition from earlier, but it's a little trickier than the first question because we don't quite have everything we need. We have the angles giving the two respective directions of the vectors, but we don't have the angle between the two vectors. That's this angle here, which we'll label theta. We can see that theta is 45 degrees plus this angle here. And hopefully you can see from the diagram that this angle is 360 degrees minus 240 degrees, which is 120 degrees. So theta equals 45 plus 120, which is 165. So using the definition from the beginning of the video, a dot b is 8 times 10 times cos 165, which is minus 77.27. So hopefully you now understand what the scalar product is and how to calculate it.